The question number 26 is the fundamental frequency of the sonometer wire increases by 6 Hz if its tension is increased by 44%, keeping the length constant than its original frequency. See, this is some experiment where the sonometer wire has given the length L and the weight is hung from this side. Then the fundamental frequency is proportional to root of T. Reason? N is 1.2 into T divided by mass per unit length. So in the second case, he says that tension is increased and the tension is become 1.4 T because increased by 44%, and the fundamental frequency of the sonometer wire increased by 6, and that's given that N dash minus N is equal to 6 frequency increase. Let's solve just by dividing. So this is 1.44 T root divided by root of T. So it is 1.44 root, which is equal to 1.2. We can return as 6 by 5. And I want to find out original frequency. And from here, N dash is equal to N plus 6. So N plus 6 divided by N is equal to 6 by 5. Cross multiply and you get that N is equal to 30. So original frequency is 30 Hz. So correct option is option number 3. The question number 27 is the first two lengths of an air column in a resonance column method were found to be 32 centimeter and 98 centimeter respectively. It is found that velocity of sound in the laboratory is 336 meter per second. What is the frequency of vibrating tuning fork? Now, dear student, what happens? This is some resonance column and this is happening. This is the second resonance length and this is the first resonance length. And see, the difference is what? Lambda by 2. So lambda by 2 is equal to L2 minus L1. So what is lambda equal to? 2 L2 minus L1. And L2 minus L1 is given because L2 is given 98 and L1 is given how much? 32. And this become in meter the wavelength. Now he's asking what is the frequency? So N is equal to V by lambda and V is given how much? 336 and lambda you are calculating from here to 98 minus 32 multiply by 100. So this will give you the frequency in Hertz. When you solve it, this answer comes to be 254.5 Hertz. Therefore, the correct option is option number 4. The question number 28 is the sound intensity level at a point is increased by 20 decibel, then the pressure amplitude is increased by the factor. Now dear student, whenever the intensity level changes, that is loudness, this is given 20 and the formula is equal to 10 log of the new intensity to the old intensity. So 20 by 10 is equal to log of I2 by I1. This base 10 if you remove, then this become, now remove the log on both sides. So that means 10 power 2 is equal to I2 by I1. So intensity I2 by I1 is equal to 100. Now the pressure amplitude is proportional to root of intensity. So therefore P2 by P1 is equal to root of 100 and which is coming to be 10. So pressure amplitude increases by a factor of 10. So therefore correct option is the second option. The question is a wave is represented by y is equal to 2 cos of 4x minus pi t is superimposed with another wave to form a stationary wave such that at point x is equal to 0 is node. Then the equation of other. Now see, if you want that there should be some node, then your equation should be like this one. This could be sine or cos omega t, whatever, like this one. Now at x is equal to 0, this the amplitude becomes 0. So amplitude becomes 0 at x is 0. That is required. That at x is a node. Now, dear students, to get this sign from the cos, we use this formula that cos C minus cos D is equal to 2 sine of C plus D by 2 and sine of C minus D by 2. And this, if you pick up the second wave, y1 is given equal to 2 cos of 4x minus 5t, and the second wave you have to take y2 is equal to minus 2, everything same but minus cos of 4x plus minus pi t, and y is equal to y1 plus y2. Then you get the resultant that y is equal to 2 sine of 4x and sine of pi t. And that satisfies the condition that at x is equal to no. So your second equation should be minus 2 cos of 4x plus pi t. And the correct option is 2. The question number 30 says, the frequency of first overtone of a closed organ pipe of length L is F1. A hole is made at a distance of L by 6 from the closed end. Now the frequency of first overtone is F2. Now what is the ratio of F1 to F2? This is the closed organ pipe with the length of L. Now its fundamental frequency is equal to V by 4L. And the first overtone is 3 times the fundamental, that is a frequency F1 given. Now he says that hole is made somewhere here, which is at a distance of L by 6 from bottom. Then it become an open tube with this length of 5L by 6, because this become now the free end. And oscillations are, the resonance will occur in the tube. When the hole is made from this, then first overtone is F2. And see, when it's open, the fundamental frequency is V by 2L, where L become equal to 5L by 6. And the frequency first overtone is second harmonic. Now, to get the ratio, so divide F1 by F2, and so divide this, you will get the answer 5 by 8. Therefore, the correct option is the option number 4.